So I want to graph this function, f of x equals 3 to the negative x minus 2. I think I will do this by doing transformations. We've done a lot of those in previous chapters. So first of all, let's take note of what the parent graph would be. The parent graph would just be y equals 3 to the x power. So I can make a quick little table for that, just so we have a few points we can plug in and draw a sketch of that exponential function. So 3 to the negative 2 power would be 1/9. Remember, the negative exponent means reciprocal. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the 1, the first power is 3. 3 squared is 9. So I can just use these to kind of guide what my exponential function looks like, my parent graph. I'm going to use a lighter color so it doesn't be so obvious. Okay, so when I plugged in negative 2, I got 1/9, so just barely there. Negative 1, 1/3, same tiny fraction. 0, 1, there's my y-intercept. 1, 3, and 2, 9. 1, 2, 3, 4, 5, 6. Doesn't fit. Okay, so let's go ahead and sketch in the exponential curve. It grows very quickly after this. Got some arrows here. So this exponential function does have a horizontal asymptote here at y equals 0. And now that I have my parent done, I'm going to go ahead and apply the transformations. So the first transformation I'm going to do is this minus sign right here. A minus sign multiplied by the x indicates the change in sign of all the x values. In other words, it flips the entire graph over the y-axis, or it reflects it over the y-axis. So the y-intercept will stay the same. The other points will all have a change in sign of their x values. So instead of 1, 3, we get negative 1, 3. Instead of negative 1, 1/3, we get 1, 1/3. So the entire graph just gets reflected over the y-axis like this. So of course this would not change the asymptote. The asymptote is still y equals 0. So let me write a note. This is y equals 3 to the negative x. Okay, and I have one more transformation, minus 2 here on the outside. So that is a vertical shift. It's going to shift down 2 units. So I have kind of 3 points I've been using as my guide. I'll go ahead and draw my final graph in a darker color. So I'm going to take each point and move it down 2 units. This vertical shift will also shift the entire asymptote down 2 units. So it used to be here at y equals 0, now it's down here at y equals negative 2. And I can draw in my exponential curve. Okay, it's not going to cross over that asymptote. It grows very quickly up here. Okay. And that was called f of x, so I'm going to label it f of x. Okay, now that I have this graph done, I can answer the questions. Let me zoom out a little bit here. Is f a function? Yes, it is. You can tell by the graph it passes the vertical line test. Is it 1 to 1? Now, to answer that one, you would apply the horizontal line test. It looks like yes is also 1 to 1. The domain is pretty simple. For any exponential function, the domain will always be all real numbers, or negative infinity to infinity. So if that's for any exponential function, that will always be the domain. The range, you can base it upon this asymptote. The function approaches negative 2, but it never quite gets to negative 2. So we will start at negative 2 with parentheses. And then, of course, the function goes up forever. So negative 2 to infinity. And then it says equation of asymptote. So remember, an asymptote is a line. It has an equation. You should never just give a number. So that horizontal line has equation y equals negative